Welcome back. We're going to look at some inverse function notation. When they ask us to find the value of an inverse at a specific point, I'm going to kind of set it equal to a variable. And for the sake of not confusing you, I don't want to really get tied up between x's and y's. I'm going to consider the x values our input, and our y values are output. And so we don't get too tied up. If you don't know what the value of the inverse is, set it equal to a variable. And I know our favorite variables are x and y, but so I don't get ourselves confused with the table, I just want to set it equal to something else. So I'm just going to use z. And what I want to note for you is just how to rewrite an inverse so that you get rid of the inverse notation. So how we would do this is use the idea that whenever you compose an inverse with itself, you get back the argument. So that's kind of looking at what we have here. And similarly, the other way around, we could also say that the function composed with its inverse the other way is also equal to x. So if I'm trying to get rid of inverse notation, I could take the function, compose it with the inverse. If I do that to one side, I do that to the other. And when I look at the left-hand side, I'm supposed to get back, based on the idea of a function being one-to-one, whenever you compose an inverse with its function and the other way around, you get the argument back. So f of f inverse 2 will actually give us back a 2. So now, what I'm trying to understand, usually it's a little bit nicer for us to read, I'm asking myself, what is z when y equals 2? And so that tells me, if I'm going back to my output, I'll be looking at the y row, and I'm looking for what happens when y is 2. And so we have y is 2, and we basically want to know what is the input. And so we have ourselves x equals 0, or z equals 0, however you would like to say. So if I want to tie this answer up, I can say f inverse of 2 is equal to 0. Now, if I were moving on to part B, I will use the same idea. And every time I see the inverse notation, I like to use the idea of when I compose it with its function, or its inverse, I will get the argument back. So what happens? We can do the same thing with part B. If I compose f with f inverse, I can do that to both sides of the equation. So that will give me f of 3. I can now use the property, then the way the inverses, in a way they cancel each other out. So we are left with just x equals f of 3. So what we're looking for, if we want to be a little bit more precise, we want to ask ourselves, what is the output and I should probably say, I'm going to say the output because I think that we get tied up with this. See if I can erase a little bit. I guess it's not letting me erase anymore. There we go. What is the output when x equals 3, the input? So if we want to look at this one more time, in our case, the input is 3. I'm going to go back to the table. So we're going to figure out what is the output. So when x equals 3, the output is 8. So we can say that this value, or the output, is equal to 8. So in our case, the output was considered an x equals 8. So be very careful. Sometimes it gets really confusing. They're using x in a different manner than the table. So I kind of go with, they're using x as a variable as opposed to what the x value actually is. Moral of the story is don't get too tied up on the notation. I would focus my energies more on understanding how do you take it out of inverse notation. So once again, if you do this a couple more times, maybe 10 more times, you can rewrite this as far as inverses. Whenever you see the inverse, you can take the function of the number on the right-hand side is equal to the argument. And we did that with compositions, but this is just a shortcut. So take a little time for that to settle in. Sometimes that gets a little bit confusing, but hopefully this helps you out.